If he gives it to somebody to check, usually what happens is he passes it over to some people to check it.
Come back. Same line that we are getting from last week.
Thank you. So thank you very much for coming back. I hope you had a good lunch, although you have been having it for the last 4 days. I hope it is good. So for this session, we are going to have a different session. Okay, there will be no lectures by either of the professors. Okay, we'll ask you to do an activity, and that activity is an individual thing, and you probably have got 2 files in your group. So what we'd like you to do is one is a set of instructions for this activity. It will tell you how to go about it, and the second is a worksheet to use in that activity. We want each of you to calculate your personal footprint. Okay? So for that, first you sit down and each of you see in 2 locations. One in your college, or if you're working where you are working, and the other in your parents' house. Like what is when you were living in your parents' house, or when your parents were there, how much do they spend for different kinds of things. So I want you to calculate your footprint, either in one location or both locations, okay? And then analyze why your footprint is higher than 1.7 GHA. Remember, 1.7 is what you said yesterday, 1.7 GHA, or 1 Earth, either one. Why is it higher than or lower than? And then come up with 3 strategies in which you will lower your footprint over the next 3 years, okay? And write a 1-page description of what you found from your data analysis and your plans for reducing the footprint. Okay, and that one-page description, 300 words, I say, in the assignment description, 300 words. Write that and send it to me by tomorrow morning, 9 o'clock, by email. And you have my email. Email is there in that instruction sheet. Send it by email by tomorrow morning. Okay. So today what we want you to do is between 2:15 and 3:15, sit here alone and fill out the worksheet and identify some footprint calculator that works for you. There are, in that assignment description, there are 4 or 5 footprint calculators, but if none of them work for you, just go online, you'll find some other footprint calculator. And then using that calculator, put all the numbers in there in the worksheet, and then summarize your total carbon footprint by saying, my carbon footprint is, say, 2.8 GHA, or 1.3 Earths, or 1.5 Earths. Summarize that, okay? So we're giving you time to do that for 1 hour, and then we'll have the next session at 3:15 or 3:30, okay? So do the calculations, you can do it now, and why we want you to do it here is, then you can ask each other about which calculator is working for you. You can consult with each other which calculator is working. But your footprint will be different, right? All of you consume different things different way. It'll all be different. Okay? So so Professor Mandla and I are going to go. We'll come back at 3:15 and then that will be the next session. Thank you so much.
We have left, and you all don't forget to be Welcome back everyone, and certainly from where we have left us, and don't forget to register yourself in your digital memories so that you can get your certificate.
Okay. Good afternoon. How is everyone? Are you all okay? Okay. How was the footprint assignment? Could you start doing that assignment? Yes. Okay. You found some calculator that you can use? Yes. And you were able to assess how much is your impact? Has anyone got the impact? Yes. Okay. Yes. You tell us how much was your impact?
It was 6.5 tons per year.
6.5 tons per year.
Yeah.
In terms of Earth equivalents or GHAs, how much was it?
regarding the carbon footprint, but the Earth offshoot, personal Earth offshoot day is 18th May,
18th May.
which is 2.6 Earth.
2.6 Earths. Okay. So the Earth has, there's only one Earth, right?
Yeah.
So if everyone lived like you, would need 2.6 Earths, right? Anyone else? Yes.
So like daily GHA, it's around global average biocapacity is 1.63 GHA per person
Yeah.
and 2.02 Earths.
So what was yours?
It's 2.02 Earths.
Yours is 2.02 Earths. Okay. Okay.
As per the daily capacity.
Okay. Anyone else here? This side? Yes, sir.
1.4 Earths.
1.4 Earths. Okay. What about you?
3.3 GHG.
And how many Earths? 2 Earths. Okay. So now we have a clear design task, right? We have to create at least one more Earth. Right? So for all of us to
Or terraform Mars.
yeah?
Or terraform, we can terraform Mars.
Yeah, exactly. Teleport to Mars, exactly. So have you thought about what and how you can reduce your footprint? And you started writing that essay? Okay. So finish it it's not very long, only 300 words, you can easily finish it, just one page. And send it by tomorrow morning 9 o'clock, okay? Thank you. So, Professor Mandel has covered some of this, okay? Well, there are a little bit of overlaps between what he said and shared. But I think it's important for these things to get reinforced, okay? So even if there's a repetition, I think it's quite okay, so don't worry about it. So in developing countries, about 500,000 people die each year from transport-related air pollution. And 500,000 people die from accidents. And this is with the urban population in developing countries is generally less than 50%. Like in India, it's 33%, right? And very soon it will be 50%. So if we had similar unsustainable transportation patterns, imagine the amount of deaths we have from direct accident deaths. Imagine the deaths we have from air pollution. So it's a very, very serious problem. In developed countries such as US, Germany, Australia, the problem is sprawl. Low density sprawl that causes people to drive great distances, so lots of resources are used to support a auto-dependent lifestyle. And the US especially has a very, very bad development pattern. So it uses lots more energy, produces lots more emissions, has very significant negative impacts on the environment. So most of you here said that you need two Earths to survive, right? The average for a person in the US would be 8 Earths. Okay, so 8 Earths. So the US has a very bad development pattern, and so that's a problem. Now this is a graph that you briefly saw in the first video that I showed you on day 1. Alex Stefan has used the same graph. And this shows the relationship between low density sprawl and energy consumption. And as you can see, on the x-axis is the urban density, on the y-axis is the amount of energy needed for transportation. And on the x-axis, places like Hong Kong that have a very high density require very little energy consumption. Like the energy consumption is so low. So you can see here, so you can see that Hong Kong here, very high density, very low energy consumption. Moscow, fairly high density, very low energy consumption. Tokyo, fairly high density, low energy consumption. Singapore, high density, fairly low energy consumption. Then European cities, and then US cities. US cities have very low density and very high energy consumption. Okay, so as India develops, India would really do well to not follow low density sprawl development like US and Australia have. Okay, so we must not in India have this kind of development pattern. In different parts of different states in the US, there are these are 4 different states in the US. And the gray line is the US national average from 1981 to 2017. So over 36 years. And over 36 years, the per capita vehicle miles traveled, the number of miles traveled per person per year has generally increased. There was a small dip after the US had a big recession, 2010 to 2012-13. During that recession, there was a small dip, but otherwise, from 1981 to 2017, there's been consistent growth in the per capita vehicle miles traveled per day. In some states, it has been much higher. In some states, it has been much lower. So the state that has actually reversed the per capita miles traveled is the state that is in blue color. Okay, that state is the state of Oregon, and this is where the city of Portland is. Remember, I told you about Portland yesterday, day before. That's in this state. So this state, they've done a very, very progressive thing, and they've reduced the per vehicle miles traveled. The other state where the vehicle miles traveled has been more or less flat for a long time is California, which is also a very progressive state, which has also put in place policies to reduce vehicle miles traveled by increasing the gas tax. Remember, I told you they put whatever the price, they put 100% tax on that. That's how one of the ways in which they've done that. But states like the state that is red in Mississippi, see, look how it has gone, how much it has increased. From 6,000 miles per capita per year to 15,000. It's a crazy number. And it's a very poor state. Very poor state. Per capita income in the state is very, very low. So when poor people drive lots, they are paying a lot of money. They're spending a lot on transportation. On the other hand, California is a very rich state. It has the highest or the second highest per capita income. And when they drive less, they're spending less on transportation. So there is a social justice aspect to it as well. Okay? So sprawl generally means low density. It also means lack of variety and lack of mixing up uses. So the city of Atlanta, for example, it's a very big city. Many of you have heard about the city of Atlanta. Its population in 1950 was probably 500,000. Its population in 2010 was about 4 or 5 million. Okay? So it went from 500,000 to about 4 or 5 million, so 8 times increase in total population. But look at the density change. Georgia. This is a state. So its population density in 1915 was 4,800. Population density in 2010 is 1,700. So imagine that. The density has come down to 1/3. And the total population has multiplied by 8. So the total spatial extent has increased 24 times. Okay, so that's really bad. So much more land is being used and wasted. So many miles of road are being constructed. Cost of construction. So many extra miles of pipes have to be laid because of road density. And then so much of road maintenance. Everywhere roads have to be maintained. Potholes or cracks in the road have to be maintained. So many more miles have to be maintained. And then people have to drive great distances. So when it was 4783 in 1950, many neighborhoods had the threshold population for different kinds of goods and services. But now when the density is 1707, many areas do not have the threshold population for different kinds of goods and services. So that means more people are driving for more needs. So although the area has increased by 24 times, the amount of vehicle miles traveled is not a simple linear increase. It's an exponential increase. So maybe people are driving maybe twice as much. Instead of 24 times, maybe 48 times now as what they were driving then. So this is and the thing is, it's happening in many cities in India. At the periphery, the cities are growing at very low density, and so similar problems are being experienced here as well. So if you look at the entire list, almost all the communities, all of these are cities that have grown in population from 1950. They have at least doubled in population, and in all of them, the density has come down. Except for maybe Austin, where the density has not come down so much, but in all of them, the density has come down at least by half. So imagine how much land is being, extra land is being used right now for this. And across the US, the number of vehicle miles traveled has increased from 10 miles per person per day. Annual vehicle miles, so 10,000 miles per year to about 12,000 miles per year, multiplied by 1.6. So 20,000 miles per kilometers per year a person is driving. Land use can make a change, can make a very big difference. How planners, how we control the development of land, it can make a huge difference. So these are three colonies within the same urban area. And this is Silicon Valley. The three urban areas in Silicon Valley. In the center of this urban area, in a place called North Beach, because density is very high, there's different kinds of land uses, and there's very good transit system. People are traveling about 15 miles per average per person per day by vehicle. Most people are able to walk, most people are able to go by bus, but and then on the other hand, on the edge of the city, in this place called San Ramon, where the density is very, very low and the transit system is not very well developed. This is in the same urban area, so it's like one part of the city of Patna and another part of city of Patna. Okay, this is in the same urban area. People are driving 76 miles per day. Why? Low density development, no mix of land uses, not much public transportation. Here, high density development, mix of land uses, and good public transportation. So land use can make a difference. Planners can make a yes.
Driving to that residents are happy because sometimes what also happens, residents don't want to have the public transport, they want to drive that car.
Yeah, it depends. Sometimes people are happy driving the car because when they drive a long distance, they can get a bigger house. Further away they go from the city, they can get a bigger house. But generally, people are not very happy, especially in this state. In California. California people like to live in dense areas. They like that kind of mix. People who, it's just the culture of the place, right? In some states, people, at least in the US,
Part of the San Francisco.
this is part of San Francisco.
In San Francisco, they're moving that.
Very close to the city of San Francisco. City of San Francisco and just around it, yeah. So look at the difference, 5 times. Just land use can make a difference, right? 5 times as much. So if you're living in the urban center, it's possible for you to live your entire life without owning a car. Whereas if you live here, in the low density area, you cannot get anywhere without owning a car. Okay? And that means more expenses, right? You have to buy a car, right? And then maintain the car by putting in fuel. So all of those things are more expensive.
So the cost of living will be high in the central part.
Depends. So if they have a mix of land uses, as they have in San Francisco, you have a full range of housing options. You have very low rent or very low price housing, but also very high end also. Yeah. And all these towns, like San Francisco, was developed 150 years ago. So all of them had that mix of land uses, mix of incomes and all that. So it's the new areas and the new cities. Like for example, Phoenix. Phoenix does not have a good mix of land uses, does not have a good mix of income. Phoenix, that Professor Mandal and Supriya are very familiar with, is a relatively young town, maybe 50 years old. And all of them, and here's the irony of the whole thing, okay? And this is why planners like me, planning professors like me are trying to change this. Phoenix is a planned town. San Francisco is not a planned town. The planned town is worse than the non-planned town. Organically before planners were there. So that's the problem. So, elements of a transportation system, and one of the first elements that I wanted to put on the slide is walking and biking. Quite often in transportation planning, we ignore walking and biking. Almost if you ask me, in planning in US, planning in India, if some student is specializing in transportation planning, you ask them, what are you thinking of? They're talking about how to widen the roads, but walking and biking is transportation. And that should get more importance, right? And that's low cost, no cost transportation. Vehicles, public, and then roads. Roads should come after that. And then maybe rail lines, and increasingly, at least in the US, people are trying to think about autonomous vehicles. Okay, so there might be an opportunity in the near future. AV vehicles might happen. I don't know whether AV is going to be good or bad. Okay, all the my transportation planning colleagues seem to think that AV is good. I don't know if AV is good. I think any V is bad. Okay. So anyway, for a sustainable transportation system, we need to have a sustainable transportation system that provides access to different kinds of facilities and amenities and helps economic development to happen. It should support safety and human and ecosystem health. It should be safe for human beings. Our car-based transportation system is generally not safe for human beings, and clearly it's bad for the environment. It should promote equity within and between successive generations. That is, a transportation system should not disadvantage certain people groups. So a car-based transportation system is a negative thing, right? Low-income people can't afford a car. Even in India, right? So many people can't afford a car. And because they can't afford a car, their lives are really messed up. They might be very smart people, but just because of their circumstances, they don't have enough money to buy a car. Therefore, they can't get from one place to other. They can't explore the whole range of employment options that might be there in the city. They can't use all the amenities that are there in a particular city because it will take so long to take a bus and go to some place, right? So therefore, that's bad. It should be affordable, fair, and efficient. It should offer a choice of transportation mode. Any system should offer a choice of transportation mode. So there should be car, there should be bus, there should be train, there should be tram, streetcar, all of those. It should support economy. The emissions should be limited. It should use only a little of the planet's resources. And it should not have huge land use implications. It should not use too much of land. And I'll show you, I think I have some numbers in a future slide on how much of land is actually spent for a car-based system. Okay, if you have an efficient car-based, a good car-based system. Now this one, this is a short talk, and we need to get this, it's a video. Can we get this video going? But I can't see the link on this, so I mean, yeah. Oh yeah, I'll have to check. No cost transportation. Vehicles, public, and then roads. Roads should come after that. And then maybe rail lines, and increasingly, at least in the US, people are trying to think about autonomous vehicles. Okay, so there might be an opportunity in the near future. AV vehicles might happen. I don't know whether AV is going to be good or bad. Okay, all the my transportation planning colleagues seem to think that AV is good. I don't know if AV is good. I think any V is bad. Okay. So anyway. For a sustainable transportation system, we need to have a sustainable transportation system that provides access to different kinds of facilities and amenities and helps economic development to happen. It should support safety and human and ecosystem health. It should be safe for human beings. Our car-based transportation system is generally not safe for human beings, and clearly it's bad for the environment. It should promote equity within and between successive generations. That is, a transportation system should not disadvantage certain people groups. So a car-based transportation system is a negative thing, right? Low-income people can't afford a car. Even in India, right? So many people can't afford a car. And because they can't afford a car, their lives are really messed up. They might be very smart people, but just because of their circumstances, they don't have enough money to buy a car. Therefore, they can't get to from one place to other. They can't explore the whole range of employment options that might be there in the city. They can't use all the amenities that are there in a particular city because it will take so long to take a bus and go to some place, right? So therefore, that's bad. It should be affordable, fair, and efficient. It should offer a choice of transportation mode. Any system should offer a choice of transportation mode. So there should be car, there should be bus, there should be train, there should be tram, streetcar, all of those. It should support economy. The emissions should be limited. It should use only a little of the planet's resources. And it should not have huge land use implications. It should not use too much of land. And I'll show you, I think I have some numbers in a future slide on how much of land is actually spent for a car-based system. Okay, if you have an efficient car-based, a good car-based system. Now this one, this is a short talk, and we need to get this, it's a video. Can we get this video going? I think, but I can't see the link on this, so I mean, oh yeah, I'll have to check. Increase the volume. It's maximum. Okay. This is a guy making a case for a walkable city. Jet spec.
So I'm here to talk to you about the walkable city. What is the walkable city? Well, for want of a better definition, it's a city in which the car is a optional instrument of freedom rather than a prosthetic device. And I like to talk about why we need the walkable city, and I like to talk about how to do the walkable city. But most of the talks I give these days are about why we need it. But you guys are smart. And also, I gave that talk exactly a month ago, and you can see it at TED.com. So today I want to talk about how to do it. In a lot of time thinking about this, I've come up with what I call the general theory of walkability. A bit of a pretentious term. It's a little tongue-in-cheek, but it's something I've thought about for a long time, and I like to share what I think I've figured out. In the American city, the typical American city is not Washington, D.C., or New York, or San Francisco. It's Grand Rapids, or Cedar Rapids, or Memphis. But in the typical American city, in which most people own cars, and the temptation is to drive them all the time, if you're going to get them to walk, then you have to offer a walk that's as good as a drive, or better. What does that mean? It means that you need to offer 4 things simultaneously. There needs to be a proper reason to walk. The walk has to be safe and feel safe. The walk has to be comfortable. And the walk has to be interesting. You need to do all 4 of these things simultaneously, and that is the structure of my talk today, is to take you through each of those. The reason to walk is a story I learned from my mentors, Andres Duani and Elizabeth Plater-Zyberg, the founders of the New Urbanism movement. And I should say half of the slides and half of my talk today I learned from them. It's the story of planning, the story of the formation of the planning profession. When in the 19th century people were choking from the soot of the dark satanic mills, and the planners said, hey, let's move the housing away from the mills, and lifespans increased immediately, dramatically, and we like to say the planners have been trying to repeat that experience ever since. So there's the onset of what we call Euclidean zoning, the separation of the landscape into large areas of single use. And typically when I arrive in a city to do a plan like this already awaits me on the property that I'm looking at. And all a plan like this guarantees is that you will not have a walkable city because nothing is located near anything else. The alternative, of course, is our most walkable city. And I like to say, you know, this is a Rothko and this is a Syrah. It's just a different way. Here's the pointillist, right? It's a different way of making places. And even this map of Manhattan is a bit misleading because the red color is uses that are mixed vertically. So this is the big story of the new urbanist, is to acknowledge that there are only two ways that have been tested by the thousands to build communities in the world and throughout history. One is the traditional neighborhood. You see here several neighborhoods of Newburyport, Massachusetts, which is defined as being compact and being diverse, places to live, work, shop, recreate, get educated, all within walking distance. And it's defined as being walkable. There are lots of small streets. Each one is comfortable to walk on. And we contrast that to the other way, an invention that happened after the Second World War, suburban sprawl, clearly not compact, clearly not diverse, and it's not walkable because so few of the streets connect. Those streets that do connect become overburdened, and you wouldn't let your kid out on them. And I want to thank Alex McLean, the aerial photographer, for many of these beautiful pictures that I'm showing you today. So it's fun to break sprawl down into its constituent parts. It's so easy to understand. The places where you only live, the places where you only work, the places where you only shop, and our supersized public institutions, schools get bigger and bigger and therefore further and further from each other. And the ratio of the size of the parking lot of this school to the size of the school tells you all you need to know about this school, which is that no child has ever walked to the school, no child will ever walk to the school. The seniors and juniors are driving the freshmen and the sophomores, and of course we have the crash statistics to prove it. And then the supersizing of our other civic institutions like playing fields, and it's wonderful that Weston in the Fort Lauderdale area has 8 soccer fields and 8 baseball diamonds and 20 tennis courts. But look at the road that takes you to that location, and would you let your child bike on it? And this is why we have the soccer mom now. When I was young, I had 1 soccer field and 1 baseball diamond and 1 tennis court, but I could walk to it because it was in my neighborhood. And then the final part of sprawl that everyone forgot to count, which is if you're going to separate everything from everything else and reconnect it only with automotive infrastructure, then this is what your landscape begins to look like. So the main message here is that if you want to have a walkable city, you can't start with the sprawl model. You need the bones of an urban model. This is the outcome of that form of design, as is this. And this is something that a lot of Americans want. But we have to understand it's a 2-part American dream. If you're dreaming for this, then you're also going to be dreaming of this. Often to absurd extremes when we build our landscape to accommodate cars first. And the experience of being in these places, this is not Photoshop. Walter Kulash took this slide. It's in Panama City. This is a real place. And being a driver can be a bit of a nuisance, and being a pedestrian can be a bit of a nuisance in these places. This is a slide that epidemiologists have been showing for some time now. And the fact that we have a society where you drive to the parking lot to take the escalator to the treadmill shows that we're doing something wrong. But we know how to do it better. So here are the 2 models contrasted, and I show this slide, which has been a formative document of the new urbanism now for almost 30 years, to show that the sprawl and the traditional neighborhood contain the same things. It's just how big are they and how close are they to each other and how are they interspersed together, and do you have a street network rather than a cul-de-sac collector system of streets. So when we look at a downtown area, a place that has a hope of being walkable, and mostly that's our downtowns in America's cities and neighborhoods and towns and villages, we look at them and we say, we want the proper balance of uses. So what is missing or underrepresented? And again, in the typical American cities in which most Americans live, it is housing that is lacking. The jobs to housing balance is off. And you find that when you bring housing back, these other things start to come back too. And housing is usually first among those things. And of course, finally, the thing that shows up last and eventually is the schools, because the people have to move in. The young, pioneers have to move in, get older, have kids, and fight, and then the schools get pretty good eventually. The other part of this part, the useful city part, is transit. And you can have a perfectly walkable neighborhood without it, but perfectly walkable cities require transit. Because if you don't have access to the whole city as a pedestrian, then you get a car. And if you get a car, the city begins to reshape itself around your needs, and the streets get wider, and the parking lots get bigger, and you no longer have a walkable city. So transit is essential. But every transit experience, every transit trip begins or ends as a walk. And so we have to remember to build walkability around our transit stations. Next category, the biggest one, is the safe walk. It's what most walkability experts talk about. It is essential, but alone not enough to get people to walk. And there are so many moving parts that add up to a walkable city. The first is block size. This is Portland, Oregon, famously 200-foot blocks, famously walkable. This is Salt Lake City, famously 600-foot blocks, famously unwalkable. And if you look at the two, it's almost like two different planets, but these places were both built by humans. And in fact, the story is that when you have a 200-foot block city, you can have a 2-lane city, or a 2 to 4-lane city. And a 600-foot block city is a 6-lane city, and that's a problem. These are the crash statistics. When you double the block size, this was a study of 24 California cities, when you double the block size, you almost quadruple the number of fatal accidents on non-highway streets. So how many lanes do we have? This is where I'm going to tell you what I tell every audience I meet, which is to remind you about induced demand. And induced demand applies both to highways and to city streets. And what induced demand tells us is that when we widen streets to accept the congestion that we're anticipating, or the additional trips that we're anticipating in congested systems, it is principally that congestion that is constraining demand. And so that the widening comes, and there are all these latent trips that are ready to happen. People move further from work, and they make other choices about when they commute, and those lanes fill up very quickly with traffic. So we widen the street again, and they fill up again. And we've learned that in congested systems, we cannot satisfy the automobile. This is from Newsweek magazine, hardly an esoteric publication. Today's engineers acknowledge that building new roads usually makes traffic worse. And my response to reading this was, may I please meet some of these engineers, because these are not the ones that I typically, there are great exceptions that I'm working with now, but these are not the engineers that one typically meets working in a city where they say, oh, that road is too crowded, we need to add a lane. So you add a lane, and the traffic comes, and they say, see, I told you we needed that lane. So this applies both to highways and to city streets if they're congested. But the amazing thing about most American cities that I work in, the more typical cities, is they have a lot of streets that are actually oversized for the congestion they're currently experiencing. This was the case in Oklahoma City when the mayor came running to me very upset because they were named in Prevention magazine the worst city for pedestrians in the entire country. Now that can't possibly be true, but it certainly is enough to make a mayor do something about it. And we did a walkability study, and what we found, looking at the car counts on the street, these are 3,000, 4,000, 7,000 car counts, and we know that 2 lanes can handle 10,000 cars per day. So look at these numbers, right? They're all near or under 10,000 cars, and these were the streets that were designated in the new downtown plan to be 4 lanes to 6 lanes wide. So you had a fundamental disconnect between the number of lanes and the number of cars that wanted to use them. So it was my job to redesign every street in the downtown from curb face to curb face, and we did it for 50 blocks of streets, and we're rebuilding it now. So a typical, oversized street to nowhere is being narrowed and now under construction, and the project is half done. A typical street like this, when you do that, you find room for medians, you find room for bike lanes. We've doubled the amount of on-street parking. We've added a full bike network where one didn't exist before. But not everyone has the money that Oklahoma City has, because they have an extraction economy that's doing quite well. The typical city is more like Cedar Rapids, where also they have an all 4-lane system, half one-way system, and it's a little hard to see, but what we're doing, it's in process right now, it's in engineering right now, is turning a all 4-lane system, half one-way, into a all 2-lane system, all 2-way. And in so doing, we're adding 70% more on-street parking, which the merchants love, and it protects the sidewalk. That parking makes the sidewalk safe. And we're adding a much more robust bicycle network. Then the lanes themselves, how wide are they? That's really important. The standards have changed such that, as Andres Bwani says, the typical road to a subdivision in America allows you to see the curvature of the earth. This is a subdivision outside of Washington from the 1960s. Look very carefully at the width of the streets. This is a subdivision from the 1980s. 1960s, 1980s. The standards have changed to such a degree that in my old neighborhood of South Beach, when it was time to fix the street that wasn't draining properly, they had to widen it and take away half our sidewalk because the standards were wider, right? People go faster on wider streets. People know this. The engineers deny it. but the citizens know it. So that in Birmingham, Michigan, they fight for narrower streets. Portland, Oregon, famously walkable, instituted its Skinny Streets program in its residential neighborhood. We know that skinny streets are safer. The developer, Vince Graham, in his project Ion, which we worked on in South Carolina, he goes to conferences and he shows his amazing 22-foot roads. These are two-way roads, very narrow rights of way, and he shows this well-known philosopher who said, broad is the road that leads to destruction, narrow is the road that leads to life. And this this plays very well in the South. Now, bicycles and bicycling are the current revolution underway in only some American cities, but where you build it, they come, and as a planner, I hate to say that, but the one thing I can say is that bicycle population is a function of bicycle infrastructure. I asked my friend Tom Brennan from Nelson Nygaard in Portland to send me some pictures of the Portland bike commute, and he sent me this, and I said, was that bike to work day? And he said, no, that was Tuesday. When you do what Portland did and you spend money on bicycle infrastructure, New York City has doubled the number of bikers in it several times now by painting these bright green lanes. Even automotive cities like Long Beach, California, vast uptick in the number of bikers based on the infrastructure. And of course, what really does it, if you know 15th Street here in Washington, D.C., please meet Rahm Emanuel's new bike lanes in Chicago. The buffered lane, parallel parking pulled off the curb, the bikes between the cars and the parked cars and the curb. These mint cyclists. If, however, as in Pasadena, every lane is a bike lane, then no lane is a bike lane. And this is the only bicyclist that I met in Pasadena. So, the parallel parking I mentioned, it's an essential barrier of steel that protects the curb and pedestrians from moving vehicles. This is Lauderdale, one side of the street you can park, the other side of the street you can't. This is happy hour on the parking side. This is sad hour on the other side. And then this is the trees themselves. Trees slow cars down. They move slower when trees are next to the road, and of course sometimes they slow down very quickly. All the little details, the curb return radius, is it 1 foot or is it 40 feet? How swoopy is that curb to determine how fast the car goes and how much room you have to cross? And then I love this because this is objective journalism. Some say the entrance to city center is not inviting to pedestrians, when every aspect of the landscape is swoopy, is aerodynamic, is stream-form geometrics. It says this is a vehicular place. So no one detail, no one specialty can be allowed to set the stage. And here, you know, this street, yes, it will drain within a minute of the 100-year storm, but this poor woman has to mount the curb every day. So then quickly, the comfortable walk has to do with the fact that all animals seek simultaneously prospect and refuge. We want to be able to see our predators, but we also want to feel that our flanks are covered. And so we're drawn to places that have good edges. And if you don't supply the edges, people won't want to be there. What's the proper ratio of height to width? Is it 1 to 1, 3 to 1? If you get beyond 1 to 6, you're not very comfortable anymore. You don't feel enclosed. Now, 6 to 1 in Salzburg can be perfectly delightful. The opposite of Salzburg is Houston, right? The point being, the parking lot is the principal problem here. However, missing teeth, those empty lots can be issues as well. And if you have a missing corner because of an outdated zoning code, then you could have a missing nose in your neighborhood. That's what we had in my neighborhood. This was the zoning code that said I couldn't build on that site. As you know, DC is now, or you may know, Washington DC is now changing its zoning to allow sites like this to become sites like this. We needed a lot of variances to do that. Triangular houses can be interesting to build, but if you get one built, people generally like it. So you got to fill those missing noses. And then finally, the interesting walk, signs of humanity. You know, we are among the social primates. Nothing interests us more than other people. We want signs of people. So the perfect 1-to-1 ratio, it's a great thing. This is Grand Rapids, a very walkable city, but nobody walks on this street that connects the two best hotels together, because on the left, you know, if on the left you have an exposed parking deck and on the right you have a conference facility that was apparently designed in admiration for that parking deck, then you don't attract that many people. Mayor Joe Riley, in his 10th term, mayor of Charleston, South Carolina, taught us it only takes 25 feet of building to hide 250 feet of garage. This one I call the Chia Pet Garage. It's in South Beach, an active ground floor. And then I want to end with this project that I love to show. It's by Maleka Architects. It's in Columbus, Ohio. To the left is the convention center neighborhood full of pedestrians. To the right is the Short North neighborhood, ethnic, great restaurants, great shops, struggling. And it wasn't doing very well because this was the bridge, and no one was walking from the convention center into that neighborhood. Well, when they rebuilt the highway, they added an extra 80 feet to the bridge. They rebuilt the bridge over the highway. The city paid $1.9 million. They gave the site to a developer. The developer built this, and now the Short North has come back to life. And everyone says, the newspapers, not the planning magazines, the newspapers say it's because of that bridge. So that's it. That's the general theory of walkability. Think about your own cities. Think about how you can apply it. You've got to do all four things at once. So find those places where you have most of them and fix what you can. Fix what still needs fixing in those places. I really appreciate your attention, and thank you for coming today.
Okay, so let me ask you something. Most people in India walk to many places. Are Indian cities walkable? Sorry?
Somewhat work.
Some are walkable? Like which ones?
The old city areas, they are walkable. But the new development that is taking place, it's very difficult to walk in those areas.
Okay. Anyone else? That's a good answer. Anyone else? Are Indian cities walkable?
And there's a gendered approach also based on that. It's easier for the males to walk on the street, but the females is quite difficult.
Yeah.
Security issues are also there, especially during the evenings when we don't have proper lighting on the streets.
Mhm.
You can't do it.
Okay. Anyone else? Any other areas? Basically, my question is: are Indian cities walkable?
Largely, no.
Yeah, my answer is: a lot of people walk in Indian cities, but Indian cities are not walkable. Just because people walk does not make them a walkable city. There's no infrastructure, there is no safety, there's no lighting.
It is not designed, it is not intended to work.
Yeah, so it is because people have no other choice that they are walking, not because it's a walkable city. So therefore, as planners, we need to pay attention to this, right? We need to pay attention even in India where most of the people are walking. We have to design walkable cities as planners. We have to make it so that women can walk, right? And we got to make it so that people feel protected when they walk down the city. So it's really crucial that we, even in India, we try to design walkable cities. The second thing that he mentioned, this might not apply so much to India right now because, but it might in the next 4 or 5 years. He said, you cannot build your way out of congestion. You saw that induced demand thing? And that's happening all over the world right now. If you have a 2-lane highway and you feel that it's more or less full, so there's congestion here, let's add another highway. Yeah, and as soon as you add another lane, within 3 or 4 months, that will also get congested. So, most transportation planners in the world today recognize that you cannot build your way out of congestion. You have to manage traffic, not build. Okay? By expanding choices, by getting people to go at different times and so on. One way to, one big thing that he mentioned was it would be good for any city, any walkable city should have good transit. Because to get to the, you can't walk across the city from one part of Patna to the other part of Patna, you can't do that. And therefore, you've got to have a good transit system so you can walk from your house or office to a metro stop. And then that metro should be good so you can get to the other part of the city. So you cannot have a walkable city without a good light rail or metro system. And one way to get that is to have a growth boundary and have the densities. Now we have densities in many places, in many cities in India, but we need to have a good metro system that can take advantage of this density and really make it a good walkable city. And this is a transit-oriented development. And this is where I just continue this example of Hong Kong that I mentioned 2 or 3 days ago. Okay, so and I think I mentioned that Hong Kong 30 years ago, 50 years ago, decided that their total land that is converted to urban areas will not be more than 30%, right? And one way they have managed all that is this. They identified land which is not environmentally sensitive, and then they went and built train stops there. And then they built a rail line to connect all the train stops. Then each of the train stops, they allowed for commercial and residential development to happen. And then after the commercial residential had happened and was working for 4 or 5 years, then they built roads. So by that time, no one really wanted a road. No one really wanted to have a car. People were used to the transit, used to the metro, and they continued to go by the metro. And so that is transit-oriented development, where you put the transit line, you put the line in places that it has the least environmental impact. You find the stops, you place the stops where there's the least environmental impact, and you build development in places where there is the least environmental impact. And then you can really manage your urban growth. You can really have a good transportation system, and it's really world class. Hong Kong's transportation system is world class. If you get a chance, you should. It's not very expensive to go. Okay.
This is an example of Hong Kong.
This is Vancouver, Canada.
They have
They also have a transit system, but I don't know if they've been very successful at reducing the environmental impacts. But Hong Kong has. It's done a very good job. And this is a neighborhood pattern that he showed in his video that we just saw. Here is the street here. Can you see this curvy street here called Collector Street? The bottom half of the development and the top half of the development have the same amount of residential space, same amount of commercial space, same amount of school space. But see how the design is done. In the bottom half, for all this residential area, there is one cul-de-sac. See this long loop here. And off the loop, there are these houses. Okay, and this is very fashionable now. In many areas, they are making this. Even in India, they are making this. Okay, and this, what happens is, if someone is living here and they want to go out, they have only 2 ways to go. They have to come this way or this way. So all the entire traffic for this entire development is on this street, and there's only 2 ways out. Whereas in the same kind of development here, if someone is living here, there are multiple ways to come out. And that disperses the traffic, reduces congestion within this area. Also, in the lower portion, there is this clear segregation of land uses. Here is this large office space. This is a large mall. This is a large mall, and here the mall has been broken up. It is in different portions. So here, if there are people, let's say these are office spaces. Okay, it's called work office blocks. These people in these office blocks want to go for lunch to this mall. They can't just walk across. They have to get into their car, come out this way, go there, park here, and then go to the mall. Whereas if the shopping area is broken up and the work areas are here, there are multiple ways for people to get here. And this is how cities used to be in many parts of the world. This is how cities started getting built in the 1960s in Australia, Europe, Canada. And now planners are trying to say, we should not build like this, we should build like this. Okay? So how much land is used for transportation in a city? In the city of Chicago, 40% of the land is used for roads and parking spaces. Can you imagine that, taking 100 acres of land which is environmentally sensitive or good agricultural productive land, and then putting it for roads and parking spaces, often free parking spaces. Okay, in my town, there is a large mall. Okay, and the large mall has got 5,400 parking spots. 5,400 parking spots. If you go on any given day to that mall, all the stores are open, everything is open, and any given day you go to the mall, only about 500 parking spots are used out of 5,400. So why did they make 5,400? Not because they didn't have the calculations right. in the US there are 1 or 2 days where a lot of shopping is done. One of those days is called Thanksgiving. You were there during Thanksgiving. The day after Thanksgiving, a lot of people go shopping. Okay, one day, a lot of people go shopping. When people go shopping that day, shopkeepers at the mall want every possible customer to have a parking spot. For that one day, they have created 5,000 extra parking spots. All that is land that was productive land that has been destroyed, taken out of the environment. Then they have put, they have put cement and concrete on that place. Imagine the cost of that. And then they have to maintain the cement and concrete. And then when it rains, previously it was ground, water will go into the ground. Now it's cement and concrete, so there's flooding. Okay, so this is not good. Yeah. Yeah, so there are many places that are walkable. My city, Iowa City, is very walkable. It is designed to be walkable from the 1960s onwards. So also the city that he showed, Manhattan, that was laid out in the 1800s, and it's primarily walkable. Manhattan, yes, Central Park area. And there are many cities where certain large portions of the city are walkable. No, I have not been.
They have designed that some part of the Pune is walkable.
Walkable,
So
yeah.
there was actually among that project, no, the straight lane, that which has been through that project is called as streets for people.
Yeah.
So through that they were able to make some of the very congested spaces
Yeah.
bring back to people.
Yeah.
So I think that is what the experience that.
Yeah.
That area has been developed into something. There's something they have supported and that area now. It's very wonderful to work in.
Yeah, that's how it should be. That's how it should be. So if Pune can do it, Patna should be able to do it.
That's because that was the reason why the mayor agreed because of these two lanes which got such a good response. He got approved that thing, and then that is where the Pune bicycle plan is right now, when it could come through.
Yeah.
And that the person who was in charge of that, he became the CEO of the Smart City of India.
Oh, really?
That guy is from Pune.
Oh,
He
okay.
handled that project and suddenly then he
became Smart City.
Smart City in charge of that.
Yeah. So Surat is also trying to do that. So Surat has got greenways. So right in the center of the city, they're building these large green corridors along the transportation, along the roads. The bicycle track is also there, pedestrian path is also there. But if you look at the numbers in many of these developed country cities, so much of land is wasted on transportation. And in many developing countries are trying to be like these cities.
But maybe transport planning says maybe the lifeline of the city should be like that. People say around.
Yeah, that's what they say, but it's
Yeah,
all
they argue, when you talk to the transport planner, they argue that if this is the lifeline, it's the vessel and it will be like so that doesn't want to say.
Yeah. Many other cities, much lesser, right? Like all the European cities, the amount of is much lesser and they are thriving.
I don't know, someone argues also that even though that the compact cities and this is there, it's not sustainable. I don't know the kind of energy they use.
No, I think they are sustainable. They are much better than many of these American cities. They are obviously the energy use is very high, but look at the land needed for the same number of people.
So why are India going wrong? It's in order to counter the Europe, you wanted to show that the
No.
different model they wanted.
No, it was not to do something different from Europe. It's just they wanted everyone to get into a car and drive, go happily. American cities are not designed to get people, not designed to make people happy. It is designed to make cars happy. Like cars have a life and cars can go wherever they want, park wherever they want, not for people. That's why. Huh? City for cars. They are making city for cars.
Even driverless car is there.
Yeah, driverless cars are coming. Yeah. Yeah. So this is the amount of land needed for the same amount of people. In the, you know, on the left you have cars, then you have buses, trains, bicyclists and people. You can see the amount of land that is needed for each of them. And here's another picture, right? Same number of people. How much of land is needed for cars, how much is needed for a bus, how much is needed for people walking. So a lot of land is used wastefully when we make a car-centric city. So, for principles of sustainable urban transportation, a lot of transportation planners, I'm not a transportation planner, say, we should aim to make our cities completely walkable. Once we try to aim to make our cities completely walkable, we'll pay attention to other things also and make it a good city. Once we make it for cars, we'll pay attention only to cars and nothing else.
Now 15 minutes walkable, we have 30 minutes walkable concept.
15-minute city, concept of 15-minute city is coming, and hopefully that will be used in India.
Has it been done somewhere? And that has been taken, whether it is efficient, whether it serves the purpose, yeah, only on the paper, it's so different.
See, many European cities are already like that. So they are analyzing European cities from that perspective. Like Copenhagen is is supposed to be the wonderful 15-minute city.
In that case, you can work by
Paris also, Paris.
Yeah, that as well.
One day you can work the entire Paris.
Yeah. So and then good connectivity, dense networks of streets and paths for non-motorized transport. Have very good transit system, good cycle infrastructure, mixed land uses, high density, try to make our cities compact, and a regional approach to transportation and easy transfer from one place to other. So all of those things are very, very important.